If everything goes right, you're supposed to have this. Okay, sounds great, right? However, you will soon realize there are some problems there. Um, the converter we have works very well for small numbers of miles. However, when it goes greater, you will have this incorrect answers there. So what's happening there? Let's recall the punch card example because I've told you that numbers stored in the computer like they are stored in the punch card. In the punch card, we are using the column to save the value of the numbers. In this case, the height or number of holes will determine the largest number you can save in this card because you have limited number of holes there. You cannot punch large number in that case. In the punch card example, we're using this we called one-hot representation of numbers there. In that case, it's such a waste because the largest number you can save is 15. However, we can do it in a better way. For example, what's shown here, we can punch multiple holes in a column. By use the combination, we can punch more, we can save more numbers there. For example, this is all 0, it's for 0. The first place 1 is for 1. It's the same as the one hot. However, starting here, starting from 2, we'll punch 2 holes here like this, which represents a 5, and we can punch more holes to represent much numbers than the 15. And the maximum number is here using the 16 holes. We can see if the largest one number is shown here. Okay, this is indeed what is used by computers, those compact representation. However, I will give you some of the terms. This actually for every 8 holes, we call a byte, and this is basic unit used by the computer. And we have, in that case, we have the lower bits. Each of the hole is a bit, so we have lower bits and bytes, and we save them, punch the holes in this order from the lower to the higher. So we have this higher bytes there. With that, now you can understand this is indeed the representation of an integer. An integer usually takes 4 bytes. That means 32 bits there. The highest, the bits were reserved for the sign. That means we're going to use the 0 for positive numbers and 1 for negative numbers there. With this representation, the maximum number an integer can save is showing this. That's a very long number. I'm not going to read it. Okay, this explains why we're getting that error, because we're trying to save a much larger number than which exceed the capacity of an integer of saving numbers. So this is called an overflow. It is much easier to understand this by thinking of the punch card example, because we have limited holes to punch this large number because you need more holes there. It's too large to punch. Okay, there is indeed easier solution called long. This is another data type for variables declaration. A long integer takes 8 bytes. That means 64 bits. In that case, you can save a much larger number as shown here. Okay, it's clear now. The simple solution is we can replace the int with long, so we can use much larger numbers there. But remember, to print them out, you have to use percentage %LLD. That's the format tag for long. So you can try it yourself. This is version 2 of Mile Converter. If everything goes right, you're supposed to have the correct number, correct numbers. Okay.